Yes, here we go. Full screen. So section 3. I know we've been pounding through the sections, but it's good to kind of keep a momentum going. So again, you should be comfortable with the word sequence and series. Today in class we did arithmetic sequences where we have a common difference. And tonight's video is on geometric sequence where we have a common multiplier. And we refer to that multiplier with an R. So D for difference, R for ratio. That you're looking, the terms will get multiplied by a constant. So that's the common ratio. Geometric sequence where the ratio of any term's previous term is constant. So let's look at our first example. So here, can we tell whether or not this sequence, and again, you can list any numbers and it's a sequence, but does this follow a pattern? And the pattern would be, do we multiply by a constant number? And I'm hoping you see that, hey, if I multiply by 4, it works, but then the plus minus means that the 4 must be negative, right? And you want to test it. You want to look, and the way they show you, it's a lot of work, but you could do this on the calculator. Take a term, divide it by the previous. Take a term, divide it by the previous. Take a term, divide it by the previous. And there you have it. And so your ratio would be, R would be -4, and this is a geometric. See if you can't figure out if this is a geometric sequence. So again, take a term, divide it by the previous term. And the answer is, it is not a geometric. What a sad sequence. No, it's still a cool sequence, but it's not geometric. I divided the 128 by the previous, got a fourth. Then I took 64 divided by 28, got a half. Right there, I'm done. I should stop, but I did the next one anyways. I divided by 8 by 64 and got an eighth. And again, these ratios, these multipliers should be the same, and they're not. So it's not geometric. It's still a perfectly wonderful sequence. But there you have it. So we have a rule for the nth term of a geometric sequence, right? We already have a rule for the nth term of a arithmetic. But now we've got a geometric. So there's our first term in the rule, a sub 1. R is our ratio, our multiplier, right? Our first example is -4. And then it's n raised, R is raised to the n minus 1. So let's go ahead and try this rule out, right? So first we have to write a rule for the sequence. So here's our sequence of numbers, 972. Then we go to negative. So our ratio must be a negative value, multiplier. So you should, in your calculator, divide 324 by 972 to figure out the ratio, which they did. So it looks like our ratio is -1/3. And so our rule, there's the formula. Our first term is 972. Our ratio is -1/3. And then you're done. That's your rule. Right? And again, I wish that book was better about this. And I know I talked to a bunch of folks today. I think when you finalize and circle your rule, you should say a sub n. I think it just makes it a more complete statement. The nth term of a geometric sequence is given by this rule. And then they say, all right, you got a good rule, let's use it. So let's figure out the 10th term. And again, you could blow off the rule, right? You could take your calculator out, take -36 multiplied by -1/3, by -1/3, by -1/3, by -1/3. Or you could use the rule, which just jumps ahead. And so you plug in 10, and you get the 10th term would be -4/81. Nice. All right, here's another example. And say one term of a geometric sequence. So they give you the third term, a sub 3, and they say it's -18. They give you the r value at 3, and they say, can you write a rule? And then we're also going to look at what the graph of that rule looks like. So you should use here's our formula again. And the more you use it, the better you'll get at remembering it. But of course, we'll always provide it for you. So a sub 1 is the unknown. We know that the ratio is 3. They told us that. And we know that the third term, n is 3, is -18. So again, sometimes a little tricky for folks to realize this is the third term, and n would be 3. And then you should say, no problem. I can solve this algebraically, right? 3 minus 1 is 2, 3 to the 2 is 9, -18 divided by 9 is -2. They did a bunch of steps there without showing. That's all right. And then we would put, all that material back in, right? So here's the formula. We now know the first term, again, book Could have been nice if they had done a sub n is equal, and you would circle this is your final answer. And whoops. And then they say, hey, can you use your rule? Can you, oh, sorry, I apologize, they didn't ask that. They asked you for a graph. And the graph is pretty neat. It's an exponential graph, right? And that's how kind of, a geometric sequence would work. You keep multiplying up. The graph for an arithmetic would be a line. It's a linear, it has a constant change. So go ahead and see if you can't write the rule for number 2 and then figure out the 9th term. Again, here's the first term. You should be able to identify that you're multiplying by, I don't want to give it away. And then the other one is here they give you the 5th term. Can you come up with the rule? Hit pause, and when you're ready, I'll show you my answers. And there are the answers. So the ratio was 2. I almost gave it away. Here's your first term, and you just write it into the formula. Then they ask for the 9th term. You just plug 9 in for n, 2, and you'd need a calculator. No big deal. This one's a little trickier. So given this first bit of information, the 5th term, you should plug in 324 for that 5th term and set n equal to 5. And then you just calculate for a sub 1, right? Negative 3 to the 4 is 81. 324 divided by 81 is 4. And now you'd put that in for a sub 1, put the r value in here. That's your rule. You want to use it, plug 9 in, and you get this answer. You can practice plugging in with your calculator. Should be able to do it one line on the calc. And here's our system of equations problem. I gave it away, but it is, right? Hopefully you kind of recognize, given the 2nd term and the 7th term, figure out the rules. I don't have either a sub 1 or the ratio, and therefore I know it'll be a system of equations. So I go ahead and I plug, I set up the formula for both of these terms. 10, the 2nd term, would be r raised to the 2 minus 1, which is to the power 1. And the 7th term is negative 320, and 7 minus 1 is 6. And so now, as an algebra student, you should say, I don't think I can use elimination. I think I need to use substitution method. And so we'll take the book here, you'll see here, they take the first equation and solve for a sub 1. You could have taken it and solved for r. You could have taken this equation, solved for a sub 1. You have a lot of choices. And then you substitute into the other equation. R to the 1, R to the 6 cancels and reduce to R to the 5. Divide by 10. There's your R value. How will you figure out A? Hey, plug it right in here, right? That's the one I would pick of the equations. Keep your life a little easier. Right, Vincent? And then we would divide by negative 2. I got your name there, Vincent. Like I said I would. Nice. And then you've got your rule. And you're done. So here they put a nice job. They presented it. A lot of work to figure out the rule given 2 terms that are not the first term. And you're not given the ratio. So again, nice system. We'll practice this in class tomorrow. Or we could practice right now. So here is one. Again, I encourage you to at least do the setup, kind of think it through, write something down. It'll help a lot when you're in class tomorrow. You'll be teaching other kids how to do it. Let's put it that way. When you're ready, hit play. And there's the answer. So again, a lot of, this is quite a bit of work to set these up. Basically, you take the 3rd term, say, 224, n is 3. You reduce, there's your first equation. Again, nice to kind of identify, okay, this is my first equation, and then I do the other term. 28 is the 6th term, so now I've got this equation, and then we're kind of asking you to rely on your system of equation skills. I solved this first equation for a sub 1. I substituted it into the 2nd equation. Whoops. And then I canceled r squared and r to the 5th, reduced to r to the 3rd. So again, we reviewed that just the other day, right? How these cancel down. I divide by 224. I get 1/8, which again, that makes me feel good when I saw the 1/8, because the 3rd root of 1/8 is 1/2. So now I know what r is, 1/2. How do I figure out the first term? I'd plug into probably this guy right here, right? And then solve with the calculator. And then they asked me to find the 9th term. So again, this is our big push problem. This is our system of equations problem. Switching to summation, we have another formula. So this is formula number 4 for us, right? And again, I will provide this at all times for you. You take the first term of a geometric sequence, and you have to know what r is. You use this formula, and you can find the sum of any amount of terms. So here's our first one, right? This is a geometric sequence. They tell it to us, and we can see the difference is 3, the ratio r is 4, and they would like to figure out the sum without actually plugging all. Somebody in class the other day was, put all the values in and then start adding up. But if you know it's geometric and you have this formula, hey, just plug in first term, r is 4. Try to write this one line on your calculator, by the way. You could try it right now just to see if you get this answer. That's the only tricky part that I see students have on this problem is, can you, navigate the calculator, especially when you have a negative r, like the next example. So our last example, again, give it a shot. Looks like our first term is 7. Our r value is -5. See if you can't get this answer, 56 million. Right? So again, in the calculator, don't underestimate it. It's a lot of work. I would recommend writing it one line on the calculator. You're welcome to piece it out, but really push yourself to see if you can get 56. I hope you guys all watched the video and hope it really helps. I look forward to seeing you in class tomorrow. Again, we're upstairs. We're not in our regular classroom. We're in B454. See you tomorrow.